In this problem, we're going to use the graph of this function to find the following limit. The limit is x goes to infinity of the function. So here's the graph right here, and I guess first of all I should say I would argue that we don't need a graph at all to take the limit of this function. In fact, this limit is pretty easy to take without a graph. But let's take a look. Here's your function right here, and as x goes to infinity, we're just going to trace along this function, and it sure looks to me like our y value is approaching a number in between 0 and 1. And if you look at these little squares, there are 1, 2, 3, 4, 5 squares dividing up this interval between 0 and 1. Each one of those must be a fifth, and it sure looks like that function is approaching 4/5. So that should be the limit, and it sure is what we would expect. Because by now we probably realize that if you have a polynomial in your numerator and a polynomial in your denominator, and the degrees are the same, then you can take the ratio of the leading coefficients as your limit. The slightly more technical way that we've been doing this is we've been dividing both the numerator and the denominator by x to the highest power that you see in the rational function. And as you take the limit as x goes to infinity, this term goes to 0, this term goes to 0, and you do just in fact get 4/5. So it works out either way.